Okay, let's get started. Um, Firstly, just welcome to our attempt to try and make this work online. Um, there will probably be some few problems along the way, so please do give me feedback if things are not clear, maybe the sound doesn't come out well, or problems with the visuals or things like that. Initially, I thought I'll do some 4-minute videos, so I'll try and do one long video and truncate it into 4-minute videos that are nice and small for use on YouTube. Um, yeah, so, and I just want to thank Crystal Lee as the first person to just upload a problem um, and give us a chance to attempt this. All right, let's just get started with the problem. So, the first point that I want to discuss is the orientation of the views that have been given. Um, Obviously, from the problem, you were requested to give orthographic views of the object shown and to draw them in first angle projection. So first angle projection, that's what we have to do. And you were instructed to make the view through the direction B. That direction B there would be as shown by that arrow over there, meaning that you're visualizing it in that direction. And the idea is that the view that you'd see from there would be sectioned along the X, Y, Z plane, meaning that you kind of imagine that you're cutting this thing right in the middle there. And with your plane cutting right there in the middle, you imagine that the half of the object is off, and you will then visualize this cut in half. And that's what your full section would look like. So by sectioning, that's what they mean by full sectioning. And that becomes one of your views. So the fact that you have to use first angle projection, and you have to also apply your sectioning techniques on this, here's how this whole thing would have worked out. So in terms of placement of views, we expect that if you recall the schematic that I once discussed, which was that you'd place a main view at the middle, and for first angle projection, what you see with respect to the main view, you'd show at the bottom of the main view, and what you see, let's say on the left hand side of the main view, you'd put on the right hand side. So that would be the left view. But now, before that, we have to first find a way to choose the main view. Now, the main view here, you can see that according to this problem, it has been selected as that one there. But in actual, so as I was saying that this view here is not chosen properly, and this as well is not chosen properly because this had to be the main view, and with that being the main view, then this as a top view would have appeared at the bottom, and then you'd have a side view that comes next to this one here as the main view. Obviously, this one here located there would look fairly different. If you had chosen the main view as indicated there, it wouldn't appear in that kind of orientation as shown here. So it wouldn't appear in this orientation there. And we'll talk about what kind of orientation you would have found there. But one of the things that I want you to consider is that every time when you do your sketches and you are now considering orientation, you will obviously use the sketch for your placement of views. And immediately after getting them right, please include the projection symbol. And for your projection symbol, I would expect the cone shape to be indicated with the concentric circles next to it. If it's first angle projection, the concentric circles would appear on the right hand side of your cone shape. Obviously, I'm using my mouse to get this sketched so it doesn't appear properly. And also include in your projection symbol your center lines. So you have your center lines that cross, and you have extended to the center lines, the center line that goes along the axial direction of that conical shape that is indicated here. So with the projection symbol included, and by the way, it's one of the key things that I always look out for. So please always have your projection symbol So we have the projection symbol sorted now, and we have to worry about the placement of the views. So in the next slide, that's what I want to consider. The view that we had, if we had chosen this as the main view, I would have pretty much expected that when you look at the main view to see what the left-hand side looks like, you would have seen it appearing in that kind of orientation, not as how it appeared earlier on. But anyway, this is an incorrect principal view. So what we would have wanted was to have this view here as the principal view. So let's now begin to consider how other points that you would have to implement as part of doing your sketches, how they would look like. So we looked at orientation, and we have seen that this here had to come at the bottom, and this here would have had to come somewhere next to the main view, and it must be all aligned, meaning that the top part must align, the bottom part must also align. And also with the top view, we expect that the top view there with the main view, they would all have to align in what appears as straight lines. So what we are now going to consider in the process of creating our views is that we do them in the right proportion. And at this stage, what you really want to consider is what I call the bulk proportion. Now, to get the bulk proportion, you are given dimensions on your isometric sketch, and you have to make use of these dimensions in order to come up with what should be the total height, what should be the total length, what should be the total breadth. So let's just quickly see what would we find if we were to do that. So we have the main view, for which the total length would be a distance from there to there. So that would be a total length there. And now we want to calculate what that length would be. So if you look on the isometric over here, you can see that we are looking for a distance that starts, let's say, somewhere there and ending up to the edge there. So we have this 100, which is the length from the opening, the center of the opening of the round profile over there. So the center, which is right there, so it measures 100 up to the edge of what looks like the front of this object, and we can determine what the distance from that center to the periphery should be because we have the diameter of 72 there. So that height should be basically 100 plus 72, which is the diameter, divided by 2. And that will give you an overall length of about 136. Okay, so now we have the total length, and we can also measure up what the total height should be. Now for the height, we have various measurements that you can use, but if you look from that line there, which depicts the very top of this object, and you will see that together with that line there, that goes to the center of the opening that takes that shape at that position there, that the distance is 92. And in addition to that, you'll see that the distance from that very same center all the way to the bottom is a distance that is 15 there. So that will give you a total height of, from here up to there, a total height there, which will be basically 92 plus 15, which gives you a total of 107. Please excuse my writing. Again, I'm using a mouse. Hopefully next time I'll try and have one of these touchscreen pens and try and use it. Hopefully it will come out better. All right. With the height sorted, now we have to figure out what should be the width. So I'm talking the distance from here up to there. But you will notice the fact that on the object, let me just actually remove this because it's not cluttered. If you look at this cylindrical piece at the end of the object, you will note that we can actually determine what the diameter is because that would be the distance from that point there to that point there, which is the same as the diameter of 72. and giving us the distance there. But as you go down on this object, as long as you are anywhere along the surface, which is about 75, you maintain that distance of 72. But now, lo and behold, from that position there, from a position here going all the way down, you will notice that the width there is different. It's 50. So it tells you that this object changes its width to about 50 right at the bottom. And you need to take note of that. This width, obviously, it's given. So the only thing is, how would you go about drawing the shape of this particular view in order to capture the actual shape as depicted on the isometric shown on your left. Alright, so with the proportions sorted, just recall that as you draw it, you will use the length, the breadth, and the height to establish what should be the size of your bounding box for your main view, and the bounding box for your side view, which will then use basically the breadth and the height, while this uses the length and the height. And obviously you will use your top view, which will take into account the length and the breadth. And just remember that you must align your views, and you must keep the same gap between the view. So the gap here must be the same as the gap there. Okay, so there must be the same gaps. With that done, then you begin to now look at the actual depiction of your object, where you're now interested to see them aligning as well. And you can already see that how we have sketched this here, we cannot from the main view, we can already start drawing some lines, and please use them as construction lines. They must be fine, and you must be able to delete them, to erase them afterwards. So we can see that that distance there should resemble the distance there. And the idea is that now you begin to focus on, while you're doing depiction, focus on the proportion of the features, because in this instance, it's important that you keep up with the right proportions. Unlike trying to draw the whole thing, then coming back and trying to make sure that the proportions are right. It's better to make sure that the proportion of your features are correct as you go along. And we can, from this view, begin then to establish what should be the height of this shape that is opening over there. And you can actually calculate it, because if you are to calculate it, you'll find that the distance there is 15 plus 8. That there's a radius there of 8, and that gives you 23. So it must be a distance that will probably come up to somewhere there. And then you can sketch the opening. And once you have that opening, you can also size how it should look like from the side to ensure that you have the right width going up to the center. And once you have that done, you probably also want to align, for instance, the cylindrical portion that is coming from the top to align with the top view there, pretty much like how it has been done up here. And you want to also align the hole that will be right in the middle to be the same size as shown in this view, and the opening of the hole at the top there, which will create an edge, a concentric circle that will be coming down here. You need to ensure that it's also aligned. And also the web, so we have a web that is located here, or the web here. So this web here, you will then indicate it in the middle there. And again, there's a question of keeping to the proportion of the features. You'll ensure that if it's 10 millimeters as shown there, that you compare it to another feature to ensure that it gets the right width relative to, for instance, that distance there versus that distance there. So you want to make sure that you get the right proportion between those as well. The next thing to do is to ensure that you basically keep to the right depictions. And for the top view, it's fairly easy as indicated. The challenging views would have been your main view, as well as this view over here. Let me just remove this again so that there's no clutter. So on the main view, as you depicted, we expect there's a rule that says you're not supposed to cut through the web. So you have the web here, and when the web is shown from that particular view, the rule says that you cannot cut through the thinness of the web. So you must show this web without showing uh, your your hatch lines. So um, this is basically how you'd show it. So that is correct. Um, but there's a little problem about the details shown inside of the object that has been cut right in the middle there. Because remember, we said that we're going to cut this whole thing right in the middle there. Okay, so when you cut it there, you need to realize the fact that you're visualizing it from that direction, the direction B. Now, past the cutting plane, you must be able to visualize all the changes in profile that are um, behind the cutting plane. So if this is the cutting plane right at the middle, then the points that are past the middle point there, you must be able to see them. So what I'm talking about is that this profile here, it shows that there's a change in plane, and you can see that there's, a change in plane there. And if it's there, then I expect that there must be a line that is going to go somewhere like that, depicting the change in plane right around the cylindrical shape. And I expect it there as well. And those are critical. They must be shown. Now, for some of you, I know that some students, they look at an object that is cut like that and they assume that actually that's how it is. But in actual fact, just remember, whenever you see these kind of shapes that indicate that something is cut, or a line that shows that it's not straight, it's kind of like wavy like, all of those, they indicate the fact that that a section has been performed on the object, but the actual object is closed, it's not cut out like that. But for the purpose of the exercise, it's allowed to be shown as cut like that. So just recall the fact that the actual object is closed. Right. Now, with that in mind, um, let me see if I can find an erase button that can actually not erase everything. Because okay, there we go. All right, that's not working. Um, let's see. Is this an erase button? No, it's not. Okay, I'll find the erase button. I just don't want to keep changing every time. So let's just. Um, we had that line there. We had that line over here. We had that line there. Now, over here, there's a bit of a problem on how this thing would look like. If you imagine that you're cutting it there, my expectation is that based on the dimensions, you can basically tell that the distance from that point there to the bottom, that distance there, we must be able to calculate it then. That distance will be basically 92, which is that distance there, plus 15, less 75. So if you do that, then you get the difference to be that distance there. And I think it's something like 17. And if it's 17, then okay, my apologies. The distance that is 17 is basically the distance from that center there all the way to the underneath portion there. So that would be 17. So it's enough distance to allow you to have that radius of 8 appearing below that level there. So the implication is that what I would have expected here is that this line here doesn't exist. So that line there you don't have. So it was supposed to be just a continuation of hatch lines going all the way up to some distance there. And then you see an area which I'll indicate in blue, basically that area there. That area basically shows you the cut that's right there in the middle, and you're seeing past the cutting plane, and you're seeing the surface that appears on that end. And that's what you see as this surface that is just the white space there. Okay, so now you can follow that. For this shape here, you have this white space here, you have hatch lines continuing up to some distance there, and you have on the inside you have this line there, and you have those two lines there that shows you the change in profile of this cylindrical shape on the inside, and pretty much that talks about the depiction of the main view. Now for the top view, remember this is the top view coming down here, so I'm just going to make points on it shown at the top here, but just remember that it was supposed to be there. Now for that top view, we have the web shown in the middle there. Now I can't remember what the page is on your notes, but you would recall that if you have an object that has a web that meets up with a rounded surface there, that you'd have to indicate the ends slightly rounded there, so they won't appear as full right angle corners. They must appear slightly rounded, and you pretty much do the same thing around there where this guy meets up with this one here. So I expected that to be slightly rounded like that, and now we see the inside hole here, which basically should correspond with that length there, and the hidden details here, because we have revealed from the main view what's going on, it's not really necessary to be showing them there. Okay. But pretty much I think the top view didn't have a lot of problems. The one view that is kind of challenged is this side view here. I'm going to attempt to draw it using my mouse as to how it should have looked like. Remember that by Friday I'm going to actually post the correct solution, so you'll have ample time to make sense of it. So for now I'm only going to give this feedback without the final solution shown properly. The idea being that I allow you to go and think about this at home, and by Friday you have time to then get the right solution, and again make sure that you reconcile the solution to the attempt to doing the problem. So this view here, my expectation is that this top end from here up to there, just change my pen again. So from here up to there, I would have drawn this to appear like a rectangle. Just remember I'm using my mouse so it doesn't appear quite nicely. So I would expect a shape that almost resembles a rectangle. In the middle, we do have the web, and this web here would have had to look like, again, consult that section that talks about webs, and this is what I would have expected of that web, and it would have had to go down all the way up to this edge there. Now what happens at that edge is that you do have a line, but this is what would happen. You'd have, because this is a web and it's joining a rounded surface, it would extend slightly and have that shape that looks like an ear, and this here would be my mistake. I see I've made a small error there, so let's just clear this up again quickly. So you have that shape there, you have that shape there, you have that shape over there. Now this top edge there actually would appear somewhere there, but I'm not going to draw it fully because how it interacts with the web, you expect the web to be rounded at the top there, and as it passes through this line it will be slightly rounded as well, so you expect a shape that looks more or less like that. And what now happens along this width here, remember that from right at the top there up to here I have the same width of 72, okay? But now from underneath this object here, things have to change. Suddenly along there, the width is no longer 72, it's 50. But for that width from here to the hidden side at the other end, that width there continues to be 72 because it's the same cylindrical object as at the top. So how this would actually appear is that you would have this thinner portion at the front appearing somewhat like that, and obviously you have that opening there, and this would be coming up to here. And now what happened is that when you visualize this from that, you will see this surface slanted. So this portion will appear slanted, and it will almost appear like another surface, a separate surface, because there you would have the top, this front edge, which I'm going to draw in a different purple color. So that front edge there is what you would appear as a line going there, and same there. And now this shaded surface that I've just indicated there in red would appear basically, I'm showing it in green, as that surface there, and also as that surface over there. And that is very important in terms of depiction, making sure that these little kind of things you do capture them as they would appear, as you would see them if visualized from the particular site that you're indicating. So that's typically how more or less your depiction of the left-hand side view would look like. Just remember that when it comes to, obviously we were not asked to do any sectioning on the front view, but if we were asked to do that, I would have expected that you could then cut the web. Let's say, for instance, if you were told that you should cut it somewhere along that plane, then the web there, you would have shown it cut with hatched lines. But because we are being asked to show that view section, then you cannot section the web there. Okay. Right. While we're at this stage dealing with depiction, it's important to do simple things correctly. And one of the key things that is that you have to continue to do right is to provide center lines. Remember, the rule about center lines says that you must show center lines everywhere where they would appear. So what we do have, if I use the orange color there, we do have center lines that would cross there and over there. So you must show it as a center line, and you'd have crossing center lines at the middle of that. You'd have a cross-sectional center line that would go through the midsection there, and a cross-sectional center line that would go somewhere there. And on this object, because this is a big hole, you must continue to have a center line that goes all the way through. Okay, and that's your longitudinal or axial center line. Okay, now that we have dealt with depiction, then the next thing to consider would be sectioning. And if you do sectioning, obviously you want to indicate the area that is solid and that is being cut by your plane, to indicate it using the hatch lines. I think these have been drawn very nicely, and the rule is that you want to show them by default at 45-degree angle. You only change that angle if the object has a profile that kind of also lies at about 45 degrees. So then you can distinguish it at a different angle. But I think how they've been indicated here, they look superb. Now moving right along, if we were to consider the next section on, just still on sectioning. Another rule that is important to observe is that you must have the same spacing between the lines, and they must all lie at the same angle. As soon as you don't have the same spacing, which is usually the temptation that people feel if they are in confined area, like say if you are in that space and you want to show the lines, there's always a temptation to make the spacing there very small because you're in a very confined area. And as soon as you're in the open space, like say there, then you start increasing the line spacing. That is incorrect. You must keep to the same line space throughout the object, irrespective of how confined it is in some corners. Just ensure that you keep to the right angle as well as spacing of your lines. The last aspect that I wanted to talk about is how you place your dimensions. And that's also quite critical, because what you want to do as the first thing on dimensions is you want to basically count all the dimensions that are placeable. By that I mean that you want to, I'm just going to clean this up. So you basically want to count all the dimensions that you can place on your object. And for that, I'm going to use the sketch as is, correct as it is, just to show which dimensions you would have placed in what view. So if we quickly look at this and we do some tally, you see that firstly you have fillets and rounds. What this means is that, generally speaking, where this has what looks like hairy lines like that, though, it implies that this here is rounded, and it has the rounds to be shown at a radius of 2, and otherwise where you have uh, fillets, you would also show them with a radius of 3. Okay, if you look at other roundings, you have roundings there that are explicitly shown, and the implication there is that you need to bear in mind the fact that these here are different to, let's say, those roundings that you have as part of what looks like a bushy surfaces. Okay. Now, in terms of placement of views, we're going to do the counting first, like I said. So let's start right at the bottom there. So we have a dimension there. It's 1, 2, 3. And what we want to do is to avoid dimensions that repeat themselves one way or the other. So 1, 2, 3, 4. I'm not going to count these fillets here, rather those roundings. 6. So we have 2, 3, 4, 5. It's 5. And we have the thickness there. It's 6. This thickness is different to this one. That's 7. And in terms of height, 8, 9. That little opening there. 10. Its thickness, 11. And that opening diameter from the inside, 12. And 13 for that thickness there. And then we have that 14 going along this direction there. And we have the diameter there, 15. And we have the inside there as 16. And actually we have another one there, 17. So we can pretty much expect to place about 17 dimensions in one of these 3 views. So you can place them there, or here, or there. All you have to ensure is that you place your dimensions such that dimension lines do not cross with your extension lines. And secondly, remember that dimension lines are not supposed to cross, with one exception, that if you have concentric circles like there, then you can only have 2 lines, 2-dimension lines that are going through the center crossing, and that's the only exception as far as dimension lines crossing each other is concerned. So you now want to place these views strategically so that you get you don't infringe on any of the rules that we mentioned. Now let's try and see if we can start, say, in the main view. So we want to look for dimensions that can actually be suitable for the main view. Now, if you were looking for those, I would argue that that dimension there, 1, and this dimension there, 2, and this internal dimension there, 3, and those 3 dimensions would basically belong over there. So you probably want to dimension this guy there, and maybe dimension that guy there from this view, and also dimension that guy there, or that guy, one of those. You can't do both of them because, or you can do both of them and exclude the total height. That's always an option. So that 75 you can exclude by just recognizing the fact that the 42 from inside, which is that dimension there, and this dimension there, which is the difference between the 75 and this 42, would be sufficient to describe the overall distance from there all the way to the top. Okay, so we have those 1, 2, 3, 4 dimensions that you can apply in this view. And on the top view, I could immediately start with the 2 dimensions that have to cross each other. So I'll take, as an example, we can take perhaps the inner diameter, this one here, and perhaps take that 72 as well. So basically, I would describe this dimension there, and perhaps that dimension there. The one on the inside, this one here, I could easily indicate it from there because I have the values there. Maybe even show it from the bottom there. And that sorts out all those dimensions here, and it also sorts out that dimension here, the 20, which I said you can easily apply from there. And now that distance from the center, from here to the front, you can obviously show it there if you want, or again as an option you can show it there. It'll be totally legit if you show it there. So any of those views will work. So it sorts out that guy. The thickness here, you can show it easily from there, or you can show it from there. Any of the two would work. Anyway, that sorts out that guy there. And this thickness here, you can't, well, if you had drawn this proper, perhaps you could try and show it there. Because remember, this would have appeared as something that looks like that. But in actual fact, the best place would be there. So this would be the right place to indicate that particular thickness of 13. And now we're going to focus on these dimensions here. So firstly, this one here of 50, the best place will have been there. But again, you can show it from here. Totally legit. It's a question of where do you have space to place your views. And now, this opening here of 15, again, you can show it there. Or you could even show it, let's see. No, this is not a perfect one. You would have shown it there. That's the perfect place to show it. And the radius there of 8, you could also show it there. It wouldn't be quite appropriate to actually show it there as a radius, because you can't quite tell how this shape behaves. So the best place is to show it where you can see the radial nature of the arc. And that total height of 92, obviously the best place to show it would be there. And what else? I think I've covered everything. And you could also leave some lettering, just like they've done here. You also have a general lettering that tells that other roundings that are on the sketch would be having a fillet of R3 or a round of R2. Just remember, all the lettering shown on the problem itself are done in small caps. You cannot do that. You must show them in big caps. So if you are to show the lettering there, it must be either round or written in big caps, and you can then tell that all of them are R2. Okay, so that's quite important to remember as you go along doing this. I think from this point onwards, you'll get the, the final solution, which I'll also upload on Pickup. But I think the video ends here. Okay, I'll hear some feedback from you guys. Thank you.